Hello and welcome to this meetup. So today we are happy to have Marton Kodok with us. You will be talking about what's new in cloud workflows, and this meetup is organized by GDG Cloud Oslo, represented by me, Rustam, and also GDG Bergen. Want to say hi, Evan, from Bergen?
Hi guys.
Awesome. All right. I think we will not do very long introduction. I think we'll leave the stage for you, Martin, and we'll be in the background. This video will be posted on YouTube on our channel, so you can watch it later as well. We'll share the links and stuff as well. So that is it. Please ask your questions, by the way. Ask them in the chat on the YouTube. And we will convey them to Marton as they come in. All right, enough introductions. I think the stage is yours. I'll remove us from the screen and go ahead, Marton.
Okay, hello there. I'm extremely happy to be here for this community to actually kickstart this channel, to be one of the featured videos, hopefully in the future. And let's deep dive into our today's topic, which is cloud workflows. We will see what it is, and I prepared a lot of code demos. So I want to do just a quick introduction about the service offering, and then I will go into my IDE and actually let's digest some of the examples and so on. If you have any questions, please use the chat at any time you want. I will monitor it so I could answer it when the example on the screen and so on. And if you want to actually ask something about it, just tune in and we will see how this is working out for it. Good. So let's see. A bit of presentation. I'm Hungarian and living in Romania. I'm a GD in cloud since 2016, and I answer a lot on Stack Overflow, so people know me from there. And my day job includes doing web and mobile development, mostly the backend architect for the clouds, and my favorite products are BigQuery and Redis, where I also publish some of the stuff. Cloud workflows today is one of the topics that we will discuss it. I have some articles posted on the Medium wall. I deactivated the paywall so you can access it freely. I have two stage names. One of the speaker, which is Marton Kodok. You will find slides and Twitter about that. And one of my coding nicknames is Pentium 10. You will find under the Stack Overflow or GitHub as well. So our agenda is pretty much very short, and hopefully watch me the advanced examples will carry on for your current projects and for the future projects as well. Cloud workflows. So cloud workflows is part of the GCP ecosystem. It's part of the Google Cloud. It's a managed service, so it means that you don't need to provision any VM or clusters or stack for it. And it integrates on top of all the services for it. Why it integrates on top? Because it's a workflow engine, it's a step engine or automation engine. And literally what's callable via HTTP, it can be automated as well. So workflow sits on top of everything and it can connect to anything which is on HTTP. It's very versatile, so it connects also the Google, let's say the serverless and compute section of it, but also the Google APIs. So whenever you are dealing with something which is, let's call infrastructure or stack, you are able to actually automate the process of those. By automating, it means that you can call any endpoints, any APIs which are available for those services. So you could, for example, start a VM. You could stop also VM. You can do SQL maintenance operations. You can do BigQuery operations. You can do even workflow itself to call other workflows, to call Cloud Run applications, Cloud functions, and all the 400 product offerings that Google offers. Then there are the Google APIs, which could be, for example, a natural language API or vision API, which are available also on the cloud offering. Those are callables as well because they are exposed by HTTP. Then the third section is anything which is callable by HTTP. That's called external APIs. It could be a SaaS API like SendGrid or Bitly link shortener or Wikipedia, Twitter, whatever. It could be any private API. It could be your application somewhere that is deployed and you call it, or other clouds as well if you set up the right authentication and connectivity for it. So on top of that, it handles authentication. So in the Google ecosystem, it has built-in authentication. For external APIs, it has simple syntaxes to get the API key and handshaking into the code as well. We will see what that code means and how you do your first workflow. If in a nutshell, if you want to add some parameters about the cloud workflow system, it's a step automation as a service. So essentially you build out steps, you do decisions on those steps, and you actually do a workflow for that. It's serverless, so it means that it doesn't need to be provisioned. It's automatically invoked. It doesn't have a cold start. When it's invoked, automatically kicks in. It has a declarative workflow language, YAML mainly. That's a wonderful syntax for actually get quickly some workflows done. It's a managed service, so it has some prices. For 100,000 steps, internal step, it's $1 or the region equivalent. For external steps, it's $2.50 for 100 operations. I think that's very fair operation price for this, and you can scale up to billions as well. We will see the built-in decision conditional executions that all the workflow language has, support for this API calls out of the box, and integration without worrying about authentication. If I want in a nutshell to show some sample workflows, let's use the diagrams first. It's, for example, you could have a workflow that triggers at 9 a.m. based on a scheduler. It may start a VM for a specific task. It can wait for 60 seconds to boot up. In case it doesn't boot up, then log the event and notify the team, for example, on Slack. This could be an example workflow for automating in a few steps on cloud workflows. Other application-based example, it could be that you receive an order and you invoke the workflow, and the workflow will do the rest of the operation, like creating an invoice, generating PDF, send PDF via email. And these steps actually could be your applications, and the application itself could be hosted on different platforms, or it could be a polyglot service as well. Often people use workflow to actually connect polyglot services. So whenever, like for example, creating an invoice, it could be part of an App Engine application with your business logic in it. Generating the PDF could be, let's say, either a Python or a Go library on Cloud Run to generate the PDF for it, and sending the PDF via email. It could be also part of the Cloud Run and using SendGrid as an external provider. What you eventually need to observe and what's versatile here is that it has reliable executions, error handling, retries as well. So even if you have some service down for maintenance, it will do the retry there with proper waiting for that. and it will continue for that. And it orchestrates microservices of your application or other APIs as well. Now, let's go into the code examples and see what this brings for us. So essentially, when we are talking about the cloud workflow, the anatomy is that we have steps. The steps can call HTTP services. Essentially, we need to always think in two steps, like the current step and what I want to do with the results of the current step. You can have some workflows, which is, let's say, functions in your coding language, or some workflows, which are available also on the internet, on recipes, and you can find out code snippets, some workflows, for example, on Stack Overflow or on GitHub collections. And it can connect anything on cloud or external service. The basic example, sequencing two steps to get data from Wikipedia. Essentially, what you see here is that there is a YAML file, Wikipedia YAML. It has the getCurrentTime name as the step name. Then it has the definition of HTTP GET, the arguments, and the result is into the current time variable. What you need to observe that this response is JSON-ish, so actually the whole JSON is part of the current time variable. The next step is actually to call the Wikipedia API based on the return value of the previous example. So you use as a variable current time body and the response of day of the week variable from the response. Then the result is placed into another variable, which is the wiki result. And there you could, for example, return the body here, the first element or the second element. Some programmers say it's valid for your API. What you need to observe is that here you have to get calls, and you work with the JSON notation when you place the results into a variable. There's some workflow, and then I will go into the VS Code actually to show you some much more example. The sub workflow and the change in syntax is that you have a main definition, then you have the steps of the main call, and you have different naming for different steps. And when you issue here a call statement, you can use a sub workflow. Some workflow lets you to actually reuse a lot of code between your scripts, and well, of course, it has parameters and it helps you to reuse everything. Before going into the next section, what's new in workflows, I will jump into the code and hopefully show you some examples for it. So I'm here in the code editor. Hopefully it will be visible for you as well. And as I do this demo presentation, if you have any questions or you want to discuss a certain aspect, you can actually leave comments, or who is on the call can join and discuss it. So what we have here first is that we have a sample file like hello YAML, and we need to deploy it. Now, in VS Code, I set up these quick run actions for me, but I actually want to go over of this because people ask me frequently how I'm doing these repetitive tasks on deploying. So essentially, when I click workflow deploy, it will launch this command. I will show you in a moment much more. Okay, good. So essentially, it runs a command gcloud workflows deploy, the name of the workflow, which is inferred from the file name in my example, and the source of the YAML file. This pane here is based on quick run, and in the VS Code, there is a tasks file. In that tasks file, I've set up these examples of doing, for example, the deploy, which is here, gcloud workflows deploy, the file name for the workflow name, and the source file as well. And of course, I use that for the full deploy as well. Now, I have other actions here. Workflow run. Workflow run actually combines the next steps. So it does a deploy, then it executes the workflow immediately. And when the execution is done, it will describe the last execution. So essentially, I'm able to deploy it, to invoke it, and to print out the response or the response from the workflow as well. So that's what you will see in my next example, because I will do all the three operations with one command by just hitting workflow run. But in order to get you better and better at this, let's do without automation this step. So I'm here with the hello YAML, and you see here that is hello world. I will go into the new terminal, and this is in folder 1. Good. And now in order to deploy it, I need to type something like gcloud workflows deploy, the name of the workflow, let's say hello GDG, and the source of my file. And this is the command in order to deploy the workflow. Now this is finished, and in order to invoke it, you can call execute. So gcloud workflows execute hello GDG. This execution is actually returning you a syntax for another command like executions describe, and you have here an execution ID, the name of the workflow and the location where that execution ID is. So either I copy this command and paste it and run it. And what we have right now is a structure from our workflow, which has the state succeeded, other state is active or failed. It has the revision ID. It has the start and end time of it, the full name in the cloud resources, and the result, which is a string hello cloud workflows. Now, essentially, as I mentioned, there is another command to describe last. And describe last, it means that the last execution of the workflow. Since this project is only used for development, it's very easy to actually do the describes, because the last execution doesn't have a name or parameter. So actually we'll describe the last execution without knowing which workflow was called and so on. So gcloud workflow execution describe last is the favorite syntax which I run. And if I exit from this, and if I click run in this pane, it will actually do all the steps what I've showcased you in one example. So deploy is done, execution is done, and describe last is called. So essentially it's your hello cloud workflows. If I change this to GDG Oslo Norway and save the file, and if I run again, you will see that immediately it's deployed. It doesn't have any cold starts, and the result is here. So you see here, this is the result. Now, this is in a nutshell the basic commands for it. We will see other commands as well as we advance further. There is a question on the chat. Is there code completion for this? Well, that's an extremely good question. As far as I know, in VS Code, there is no code completion, and this is something that I've started to actually develop, but I didn't have fully time to actually get it down for it. The good news is that Cloud Code is getting support for more and more services, and we already have YAML auto completion for some of the services. So hopefully it will reach workflows as well. I cannot tell right now if it has the workflow code completion, the Cloud Code, or not yet, as I didn't change recently, so it might be there, but I'm not sure of that. Anyway, I've been dealing with cloud workflows for a lot in the last year, and I didn't had to use the code completion because I built out generic examples, some workflows, and I actually copy paste from my snippets those things, and those are extremely helpful. And whenever you develop with a new API, you have on one of your screens the API parameters, which are custom to that API, and then you type it. So VS Code is not able to auto-complete the API parameters attributes of any arbitrary service. So that would be wonderful, but we are not there yet. Good. Sorry for being in this introductory, but I want to actually go much more deeper in this. Hopefully you will love it as well. If you have any questions, feel free to ask, because I will stop and answer it. Good. So let's go further and let's see what else we are going. You may wonder, and you haven't asked, on which GCP project did this go? And essentially, hopefully you were familiar with the gcloud utility, because this is tied to the project, to one of the projects as well. In the VS Code section, there is a status bar here, and there is this entry here, Marton data, and this is by a plugin, and the plugin called GCP Project Switcher. And this GCP Project Switcher in extension, it happens that I am the developer of the extension. I built it in order to actually get me a quick representation on which project I'm on, and I'm able to switch project very easily. So go ahead and check it out. It's called GCP Project Switcher, and it's for the VS Code extension. Good. I'm going next to the other comments as well. So we had the hello world example. Let's use one of the get statements, and I will be quick from now on. The run, deploy, execution, describe will be executed directly, and I only explain the results for it. So right now we have a HTTP GET statement with the URL. Wikipedia offers an API, it has an action, open search, and it has a keyword. It returns the top keywords inferred based on that key. So essentially this is the response from it. Very quickly, if I change this to Norway, for example, I can run it again, and you will see in a nutshell how that goes for it. One of the snippets that I use is actually this get statement in order to return the system as well. As you see here, these are one of the top keywords that is on Wikipedia, and it's returning for the Norway keyword. Boom. Okay. Next one is combining the example from one of the previous codes with a variable. For that, I will actually skip this example because it's somehow the basics stuff. Often people ask me that, okay, I get one of the results for it. Let's say that wiki result is coming right here, and how I enrich that information, how I add it to another element of it. Well, you could have a further step. I called it enrich step, where you assign to my dictionary, you assign a specific variable from that response. And as you advance further, you keep adding variables to this syntaxes. It's extremely great that you can build out the dictionary as you go, and the state of this is kept for you. And workflows can be paused for up to 1 year. So for a developer, for the state to be there in 12 months from now, without dealing with an external database or dealing with something, is extremely helpful. And that's something which I really love. If I run this example, it will be deployed. It will call the this function, which is actually just returns a basic stuff like current time. Then from there is day of the week is something that's being returned, and you see here that this is the result, return result. Yeah, I need to run the execution again in order to get the statement. So succeeded. And what we have here, return, where is the return? Wikipedia, I need to check it here. For some reason, I expected something else here, and I am not. I like to work for the week. Okay, succeeded. Result, return. I do have a return somewhere here. No. Okie dokie. Good. Good. So, yeah, I'm confused a bit, but it's here. So, day of the week is one of the keys. Wiki result is another key, and for some reason I'm not able to see the name. Yeah, I was confused by here. So last name and name, I found it. Okay, sorry for this pause. It's there. No, good. Let's go into much more deeper examples. As a syntax construction, you are able to build out dictionaries in different formats for it. I won't run all these examples for you. You can build out exceptions, and you have a try and except construct in order to actually catch exceptions. For example, authentication problems or API capacity, like going over the quotas or being too fast on an API. In Cloud Workflow, because it doesn't have a cold start and it can spawn in parallel, you often, the problem that you will face is that you will reach the calling API's limits or the third-party limits of that. So you need to actually slow down in some way. Well, in the except sections, you also see a switch statement with conditions handling, and each action is, let's say, a new step in the workflow where you are able to actually return some of the options as well. Then there are expressions. So there is a full page where you can have different expressions for string, calculations, converting something. All these are part of the manuals. On the retry, this is also customizable, and one of the features which I really love is that you are able to add a wrapper with try retry around the HTTP statements, and you have a default predicate, which is this is the notation, but you are able to define your own predicates as well. I didn't have to define my own predicates so well, so this is configurable a lot. It has the max retries and the backup attributes, how you want the backups to actually slow down. And these are really helpful examples for that. And to answer again for the code completions, this shows you that you won't build out this as a code completion. You actually copy paste the whole section and you reuse it. Because you will face out also with exceptions added into this block as well. And often you will put this into a sub workflow, so we'll have only the URL and the arguments of the main calling piece of it. The rest will be hidden into some workflow in order to be much more compact for you. You have a bunch of string functions in order to actually do processing of the results. It means that connecting services needs parsing splitting, finding, lowering, uppering construct strings, and that's really helpful for you. Good. I'm closing some things here. Then you have some workflows, which I already shown on the slide share. So here you define the name of the workflow, and then you actually call by parameters only the workflow. And the sub workflow could be literally long for you in order to execute the statements as well. You have the switch statements. You already seen briefly this in one of the examples already. Now, I don't want to go much more deeper into the language construct. Let's see some basic examples. So I will close these functions here. Let's go into some of the future stuff, and I will continue with the presentation. So what's new in workflows? Functions, string, JSON, iterating syntax, map, dynamic keys are added as a language construction, and you are able to use it as I've shown you. This is the string functions in a nutshell. The resource limits have been increased, so essentially you have 256K in order to run your application, to process the APIs. So this means that whatever result you are reading, it must fit into the memory as well. Scheduling workflows from the UI. I didn't showcase you the console, but in the console you are able to actually schedule the workflow from the UI. It's a handy feature for those who actually use the UI to build out the workflow as well. Also, there are some visualization boxes, so you will get nice diagrams about your workflow, especially when you have a bunch of conditioners and side workflows running inside your full algorithm. Now, one of the things that relatively is new is connectors, built-in authentication, retry and long operation. And let's see how that goes in practice. So I will switch to the VS Code and I will show you how that works. So essentially in this example on the screen right now, we have a bit.ly shortener in order to shorten this long URL. And the workflow itself, it defines the URL for the bit.ly service, which is external to Google Cloud. And you need to do the authorization. And here you have an API key, my API key placed here. I would say that this is unfortunate and this is not something how we want and to use this API key. But whatever, this example fully works and it will return a short URL. The evolution of this example is that get this API key to secret service. Secret, not service, sorry, that's from movies. Secret manager from GCP. Secret manager is an API and a service inside the Google Cloud to actually store your secrets, your API keys. As being a service, it also has an API. So if you look up the API, how to read out one of the secrets, and there are plenty of examples of that, you then have the step. I want the step to actually get my secret from that API, from the Secret Manager API. You will find out in the manual a link what you need to call it. Some people ask me, how do you find these elements of it? Let me show you that. So let me show you what's in here first, and then I will show you how to locate this URL. So essentially, this is an URL which has the projects as an option here. It has the secret variable. The secret variable has been defined here, bit.ly API key, and I want the latest version of it. Of course, the API supports getting the previous versions and so on. What you need to observe here is that it automatically works with the authentication because it's inside of the Google Cloud system. So essentially, the invoker service account of the workflow, if it has access to read out that secret manager operator, it will be allowed to do so. So that means that automatically will infer the permission to execute this API call. Once the API call is done, it needs to be decoded because it's base64 decoded, and I store this API key into decoded secret. And the decoded secret I then use into the Bitly service. Sorry. Now, let's see in the example. So when we are here into the interface of the Google Cloud, we have Secret Manager. Let me show you the Secret Manager. The Secret Manager, it has two definitions: Bitly API key, SendRead API key, and so on. So I have here, and the key was created almost 2 years ago, so it's there. Now, in order to get that API key, I can read it by API from some workflow. How do I locate an API? I go to this connector reference, which is the manual for workflows connectors. This is workflow doc reference Google APIs. And here on the left, I have all the APIs which have connectors. But we will see what this means. First of all, I want to actually show you the Secret Manager API. Secret Manager good. Let me just open one more thing here. Good. So Secret Manager, list locations, get, good, versions, and get, good. So we are now into the Secret Manager API documentation. You will be able to locate this page or any other Google API page on the internet. And here you can read out that you need to do a get statement. You have to combine this URL in order to get that secret value or the definition for that secret value. Well, this is what you see here is transposed into this section of it. And this is how actually, if I want to, for example, do the list statement, then I need to call v1, the project, secrets, and /version for it. Or if I want to, for example, do a destroy, on the destroy, this is a post statement. So I will write here HTTP post, and I will do those operations for it. Good. And this example works out. So if I actually run this example, let's see what we'll do here. Good. So it ran, and the short link is this one. So you have it here. There is that. Now, what it happened is that it called the HTTP GET statement. Now, let's go next, and I will show you on the slides what's the new things that they added to Cloud Workflows. They added connectors. Connectors means that all this stuff which was a simple HTTP statement and it was long was replaced by a Google API dot notation, Google API Secret Manager via project, secrets, versions, access string. And here you have the Bitly API key as a parameter, the secret ID. And the connectors, it means that you no longer need to know exactly the get or the post API statement. You instead locate the connector inside the Cloud Workflow Connector space. So in the Workflow Connectors reference, you are able to actually infer where that version, access string, the access string. And you have here the connectors copy-paste snippet. So this is actually the snippet that you need to actually grab and use in your in your workflow definition. Of course, here you have other examples as well. So, for example, let's look up BigQuery. You can have job get query results. And let's scroll down. And here you have all the examples which you have for the get query results. And you don't need to actually build out the full HTTP part of it. I love the connectors, and probably these connectors will get the auto-completion support because these are strictly defined and are possible for the names. But for the attributes, I think that's part of the API documentation. You always find here an API documentation link, which yields to the underlying API of the BigQuery service or the product offering that you are checking. And each parameter is described into this page for you as well. Good. If you have any questions, then ask now about this feature because we are moving next. Now, good. So here you had the long version, and I'm opening now the shorter version. So essentially, there is a workflow for get secret and shorten with bit.ly. And it will run this syntax, the shortened syntax as well. It's a much more shortened syntax for it. Good. Next stuff. Let's see what's in this presentation more. Of course, the connector, it has all the retry timeout, and it actually replaces some of the things that it's available as a configuration. And here is a table at the time when I do the presentation, which operation is helpful for long-running operation. Yeah, I need to explain here the long-running stuff. So whenever you call, for example, the BigQuery in order to run a query, it's a 3-leg process in the API. First is to actually initiate the job. The second, to see the job if it's finished, like constantly polling if it's have you finished, have you finished, have you finished. And then the third one is get the results of the job ID. Essentially, if you were in the HTTP definition of the workflow, you need to define 3 long steps in order to do all those by fully only HTTP. But with the connectors, all this operation is actually handled by the connector, and you have access to a connector that will do in one step all the operation, like initiate the query, wait until completion, and return the results for you. It's very handy syntax in order to run it. Also for CLUD build, because the CLUD build can take 10 minutes, and it has different status updates as well. And there are other products, and not only those that are on my screens for long-running operation in the connector. Often people, when they are developing automation and cloud automation in their own libraries, they need to build out all the underlying steps as it was the API. But in Cloud Workflow, the syntax is much more easier. So you could, for example, replace in the codes, in the orchestration code that you have for one of the application, 1, 3, 4 leg step, replace with one simple workflow to combine those by using the connectors. And we do those things as well because it's much more easier and it's a controlled way. Call me a workflow which will actually return one of the state after it finished and so on. So it's really helpful. Now, next stuff is callback endpoints. Enables async executions or human in the loop. So it means the basic example, human in the loop. So the workflow starts and at some point it needs to pause, wait until someone else resumes the workflow. And for this, there are programmatic callbacks in order to pause it, listen for the event of the resume, and then continue on the workflow. So essentially, in the code section, you need to have 2 code blocks. One is creating the callback and setting the method, either get or post callback. This will pause the execution of the workflow. And Next, you will have an await callback. The await callback is something that you are creating in order to resume the callback. And here, whenever the timeout could be up to 1 year. So that's very helpful, for example, for a long stop or a long pause or a full sleep of the workflow. You can pause for 6 months, for example, to wait for the feedback of it. And here, the wait callback is actually the code block which will resume the workflow. It has the callback details contains a lot more details, and it can read out any variables or parameters which you have passed to that URL. Essentially, this creates a URL, and sometime in the future you need to call that URL externally, programmatically. Let's discuss now the anatomy of a cloud workflow. The workflow execution starts. It could have parameters, and it's in running state when it does step 1, 2, 3, and so on. And when it's finished, it gets into the succeeded state. Essentially, if there is a timeout, it goes to the fail state. Or if there is an exception, it goes to the fail state as well. Now, let's discuss about this line here, which is await callback. One of the steps could actually stop the execution of the workflow, or let's say better, pause the execution of the workflow, set up a listener for an endpoint, a HTTP endpoint, and wait for a signal, for an external signal there. Essentially, that signal, that event will happen, and it will process an incoming call on that endpoint with some variables or parameters added to it, and it will continue the execution of the workflow. It's a very handy feature to actually implement these stuff for it. This could be also developer feedback loop. You could have an exception where you don't know your workflow what to decide or what to actually do of it, but you still want to keep it active in order to continue it. What you are going to cover is that you set up a listener endpoint, and the URL you are actually sending to a Slack channel or to another service where to actually ping back and listen, because this URL you need to save it. It's not inferable, so you need to save it. When this listen endpoint is being set up, you need to save that URL in order to be able to connect back and knock back on this workflow as well. And you are able to actually knock back with parameters. The parameter could be actually to stop or to continue and so on. If you don't operate on this, then it will time out. The callback will time out as well, and it will go into the fail state of the workflow as well. Good. It's a modern way to actually avoid sys, sleep, wait, and tracking tables and polling. So often people set up tracking tables for the variables, to statuses, to get resumable state of the workflows and so on. But here, with the state maintained for you, it means that you no longer need to actually do tracking table. It offers an authenticated webhook endpoint. It timeout up to 1 year. It's event based, so it's fine for developers. It has a full callback details. It means that it holds headers, query, body, raw, and JSON as well. Good. So this is the callback. Let's see in demo how this is working out. Sorry. So let me close these examples from here. Let's open the connector one. And let's see what's this example is a bit long. Where I have the short example. Let's go back basic. Yeah, this one. So, what we have here is that, let's see what steps we have first. So we have 4 steps. First, we are creating a callback, which means that we are setting an events create callback endpoint with a get type of callback. Then we are logging the callback URL. This is how we save or we log the callback URL. Then, in order to resume it, we have an await callback, and then you let the callback request as an action here. I don't do actions on the parameters and so on. Let's see in practice how this is working out. So right now, let's first deploy, and I will do the steps one by one. So I'm deploying this workflow. Good. The workflow is deployed. Boom. Now I'm going to execute, but before executing, I want to also see the logs of the system. And in order to see the logs, I have another option here, which is it will be here. So this command is gcloud beta logging tail. It's a nice command. It was recently added to the gcloud palette, and it's in the beta features, logging and tail. And this will be actually streaming, and it will be fast changing when we do the executions as well. Good. Now I have the basic callback workflow deployed. Now I need to execute it. Execution, it started a new pane here, and execution is started. What I see here in the first one state is that it produces logs in order for the executions, but I'm not more interested in these logs. I know that the workflow has been executed. Okay, I have this command here to describe this execution. Let's see how what that tells about the current execution of it. So it tells that it's in active state. It means that it's running. It's in active state. Essentially, what happened here is that it's waiting the callback event to actually get it resumed, to actually do the next step of it. But for that, I need to also locate the callback details URL. Let's see if we have it in the logging section somewhere here. Yeah, it's here. So text payload, listening for callback on this URL. Let's grab this URL. Okay. So that URL is there. There is the callback listener, which we need to action for it. Good. Now, in order to action it, we could run just a basic command for that URL. So I'm placing here the URL. And this is running a curl statement, authorization, getting from an authentication mirror, in order, because this needs to actually, this is not a public URL. This is a secret URL that you need to authenticate for it. And you authenticate using the Google libraries, or this is a short syntax to actually get the print token for that. But I will run this on another system, and I will run this in the console and in the cloud shell in the cloud. So essentially, I will wait for this to actually kick up and to actually, hello. I've been using this recently, so I don't know why you are waiting for it, but I will wait for you to boot up. So while I do this, I will, once it loads up, I will use the cur statement to actually call that URL. And I will paste here the command. And I will go back and let's see the status of the execution. So it still says active. Still says active. Now I'm actually running this. Yeah, I'm authorizing to do this API call. And it returned nothing, and that's good. No errors here. Now, if I go back here and request another describe, let's see what's happened. It succeeded. So essentially, and what you see here is that I have the full execution of the body of it and so on. So I didn't use any body in my response, in my callback, but I have access to that fields. So if I could, for example, to read out something from headers or from body, I could actually continue here with using body and probably a variable name of that syntax for it. Good. Now, I think that we are getting soon to the end of this. So that was the callback endpoint example. Now, soon, hopefully next week, there will be the event arc integration. This will be in preview. Right now, you can end this your project by filling out the form on the page of the event arc system as well. This is in preview. It will be launched for workflows hopefully in a couple of days or next week, hopefully this month. What this is about, Event Arc is a service that delivers event from Google services and your own apps as well to whatever service destination you set up. Right now, the trigger is possible for Cloud Run services. And right now, you can actually trigger a lot of stuff on it. So imagine that whatever has a log trace, it's an event and you can react on it or you can observe that log entry as well. And that trigger can actually do amazing stuff inside your cloud architecture. Essentially, it's built out on Google Cloud Services and custom sources as well. So even if you have an application outside of the Google Cloud, if you publish to PubSub, that eventually produces an event. The event core will pick it up and it will deliver to either Cloud Run or Cloud Workflows how you set up those things. This is really, really helpful and opens the way up to 3000 operations that previously was unimaginable that it could be. It could be just a simple log entry that has a state or a flag, for example, for a trace operation to kick on a developer workflow or to observe a state of an entry to an unimaginable scalability issues or maintenance information that's placed into the logs and you need to react with an operation to mitigate something. So it opens the world for a broader scope of this. Now, and into the finer stuff, I've wrote some articles about cloud workflows. So essentially you have a tutorial on Marton Kodok Medium about Firestore backups the easy way with cloud workflows, which means that there is a cloud scheduler which starts the cloud workflow, which will issue the cloud Firestore command, and it will place the backup on the cloud storage. Go check it out. It's a quick example in 30 lines of code and so on. There is another example to actually use Cloud Workflow to load cloud storage files into BigQuery, which means that the Cloud Workflows will kick in, or you invoke the Cloud Workflow, will look on the cloud storage folder or a bucket, it will do the for each, and it will load the data into BigQuery. You have options to actually infer the table or partitioning from the file name segments with the string functions as well. Go check it out. This tutorial with full code is available as well. Then there is something extremely extraordinary, as I say. If you have a Linux VM and you need to run a custom shell command based on a serverless environment on the middle of the night, you could achieve that. You could have the VM to be actually stopped and you only need to wake up for one single command in a serverless way, like open up the VM, start the VM, submit the job and the task, and then stop the VM. Like, it could be a serverless thing for it. Maybe something that you cannot run in a serverless environment because you don't have access to disk, or it doesn't fit into the serverless environment memory and you need to run a full VM. This is a complex example. Essentially, the start VM uses an API call to kick in a compute engine instance. It will wait to boot up. Then, in order to run the SSH statement, which is, let's say, SSH and then shell execution, that's not possible via API. So there is no REST endpoint inside your compute engine VM. Essentially, to run a shell statement, it needs to run a cloud build job. And the cloud build job could have a statement which uses the cloud identity aware proxy in order to connect by firewall, by the identity aware proxy to your compute engine and run the shell command on the compute engine. So the real trick here is by issuing an identity aware proxy, connect to the compute engine, you set up the firewall to accept identity aware proxy as an authorization layer, and then the shell statement is executed on the Linux environment. So essentially the submit cloud build, this is an API call, a HTTP call, but since cloud build is built on the Linux system, the identity aware proxy can connect to another machine and can run the job on the shell that on your VM, that on that shell, for example. And then you stop the VM. This is a full example available also by me as an article. The cloud workflow system is easy to build and operate. It scales out. I didn't tell you too much about scaling out, but it doesn't have a cold start. It doesn't do any state, but it scales out so you can run, I think, 6,000 operations per second, something like that. It handles errors, timeouts nicely, and it has a fallback, reference, and all the stuff that actually developers need to have a clean, retrievable code. Out-of-the-box support of the Cloud API, so it has shorter syntaxes. It's auditable. I say that it's important because managers often administrative task or orchestration task, they wanted to keep it auditable, like log every action of it. So Cloud Workflow is auditable, so it has a trace for it. Enable async workflow with callbacks. It opens up new ways for doing human in the loop and actions or something that happens in the future after the workflow has been initiated. Okay, and we reached the final slide. And if you have any questions, it's time to post it right now in order to answer it. So the possibilities are endless. I would say that developer stuff are interesting, automating the cloud, shell script replacement, orchestrate DevOps workflows, connecting services that never been possible before, or combining long-running operations, or combining 3-4 API legs into one single workflow. Those kind of developer possibilities are actually helpful. Then there is also the industrial, retail, and marketing ways. Like, for example, you could have a workflow-based emails, discounts, promotion built out. You could build out a visual editor in one of your preferred languages and UI in order to develop arbitrary workflows that generate into the workflow YAML language, and you get a full workflow system for your projects and for your clients as well. Good. So, whatever questions you have, please post it in the chat. I'm happy to answer it. this was today's presentation, demoing some of the new features about Cloud Workflow and serverless orchestration. I need to mention that orchestration no longer means that you orchestrate a stack, you no longer orchestrate Kubernetes engines, you orchestrate services, you orchestrate APIs, you connect services that wasn't possible easy before, but now you have a way to actually connect those services. And with the coming event arc integration, it opens with 4,000 operations that was unimaginable before, which to react and build out much more self-healing, state observations, automatically kick in some operations or stuff or scale or actually resize clusters. I'm working on a new article about BigQuery and BI engine. It will be posted this week to the Medium wall as well, so go and check it out. This presentation and similar ones are available on SlideShare, so you can go and check it out, my work as well. And that's all from me. Let's see if you have
Hello.
any questions.
We are back. Great presentation. Thank you very much, first of all. So it's been really fun sitting in a backstage and listening to your talk. So thanks.
Yeah, I have one question. What is Cloud Workflow based on? It should be some open source technology in the bottom, or is it something Google proprietary?
Well, as far as I know, because I'm not a Googler, I'm just a developer expert on one of the topics of their services. As far as I know, it's a proprietary technology. They don't build out an open source. And we didn't had in this pandemic year meetings with engineers where they share insights how they build out, so I cannot refer that information back to you, but as soon as the meetings resume, we will certainly ask what technology, what stack, how they scale, what the region, those kind of discussion you find out when you talk with different engineers at conferences and so on. So it will be the future to actually find out. What I love is that it doesn't have a cold start. So if it was an open source contribution, I would say that it had to be waited in order to boot up something. But this doesn't have a cold start. Like, I mean, they put there an infrastructure that immediately runs the workflow, and it's really helpful to actually have this service as well. I would say that even open source offers a lot more actions, like connectors and so on, but this is focused much more on cloud operations. And on cloud operations, reducing the syntax is extremely helpful. So you can combine, also do this workflow and do the open source workflow. So if you want to actually combine those things, you can, because one step could go outside and then come back. So the world is endless, or possibilities are endless.
Yeah.
Another thing that we kind of talked a little bit about in the backstage with Eyvind was how to debug this. I mean, do you have any tricks and tips and tricks for figuring out what went wrong and how to fix it? And like just looking through logs probably is the one way. And is there any other tips and tricks?
Yes. So in order to debug it, I would say that logs certainly are the way to actually see what's going under the hood. So those things. And the other is that you can inject attributes or parameters into the workflow. And when those attributes are injected, they could produce you, let's say, a table or a structured information, which I wouldn't say it's a log, it's maybe saved somewhere. So I would see that, for example, someone could build out a UI that it's visuable and it's much more appealing for a developer for debugging cloud workflows. And that UI will need a database backend to actually run that interface. Having a database, you could have in your workflow a step that will feed information to that information. And you maybe having a pool of all workflows, you may want to only, let's say, paint 1, 2, 3 or randomly some of the workflows, and that information to actually feed into the database, and you do it from there. I would say that Elasticsearch, Kibana, and those kind of things are a good way to developer debugging. So often companies just keep those systems to actually run over the structure, the logs, or to analyze user agents, or seeing any developer variables, developer actions, and so on. So all the organizations, companies that have those systems ready for Kibana for everything, they could touch this workflow as an addition, as a complementary system, and seeing the debugging as well. But as a developer, right now I'm using the logging and printing and having a specific dictionary. So I keep
That's actually a good point.
a developer dictionary in my workflow as a state, and I keep adding their information. And that dictionary holds the information up, like the execution. Also, there are logs with the execution states as well that you can analyze it. But those could be 50 lines, and your dictionary could be one step, 2 steps, 3rd step, and so on. So this is how you debug itself. In a simulator or those kind of things, they don't exist yet, so I'm not aware of any simulator or doing breakpoints, to say so. People want breakpoints, but this is cloud. It's not with breakpoints. We are not in a programming environment.
No, but it's, I think I really like this, the hash map kind of approach. I mean, that it kind of can be quite good for some applications, can be for like status things, how far it has gone through different stages, and all this kind of thing. So that actually can be quite a nice tip, I think, to people wanting to try it out. That's really cool. Any other questions? Anything else from your side, Ivan?
No, I think I'm good.
I think I'm too. So I think it's time to say thank you very much again for joining us, and thank you for doing this talk. And we're looking forward to screenshot. Nice. And we're looking forward to more talks with you. And we actually already next week we'll be having another talk by another fellow GD, and we'll be doing a talk about the cloud costs and how that can be optimized. So that's a little bit of advertisement at the end of our broadcast, and I think it's about time to say thank you all and have a great morning, afternoon, evening, wherever you are. See you soon.
Thank you for being here.
Bye.
Bye. Bye.